Keeping on the topic of input token optimization, something that is an absolute must for large static blocks of text is making sure that your system prompts are structured for caching. If you're not aware, caching is essentially sending the static blocks of system prompts or whatever to the agent, and it just hangs on to that for future calls. Okay, so this is fantastic because you can see a lot of system prompts have the same message, base message, documentation, context that prepends every message. So if an agent can hang on to that, it on average costs about 90% less in tokens than it would if you sent the entire text, right? So anything like you're a specialized customer service assistant with the following guidelines, right? And then your guidelines would include documentation and anything the agent needs to complete the task appropriately. That agent can hang on to that and save you a bunch of money. So if you're not doing that already, that is the biggest single lever you can pull to optimize your input tokens. But what we see often as well is people have implemented system prompt caching, but it's failing silently for a couple different reasons. Maybe it's the config wasn't appropriately written for whatever model provider, or let's say the system prompt changed and it invalidated the cache. That can be a real silent killer because you're paying 90% more than you thought you would have had to while this is failing in the background. So if you're not already doing the system prompt cache, it is absolutely, it's the difference between something being affordable and completely unsustainable. And if you are, you want to make sure that it is actually working appropriately, right? So caching is effective for static blocks of text that the agent can hang on later. And it's probably something you shouldn't worry about if you have consistently changing context or user content, or your system prompt is less than 1,024 tokens, which is cost insignificant as it is.